Okay, so for our last section for chapter 6, we're going to be talking about molarity. And so molarity is specifically going to be dealing with solutions. And second, there we go. So solutions are anything pretty much we're going to be talking about, or anything that's going to be dissolved in water. So, right, we're already ready for our final review. Homogeneous mixtures, those are solutions. So remember when we broke down matter, right? And we had like pure substances and mixtures, a homogeneous mixture, that is a solution. So whenever we talk about solutions, we're always going to be talking about their concentrations. So when we did like the atomic staircase lab, we had the solutions that we used to show the colors of the flames. Those have specific concentrations. And so we're going to talk about those concentrations today. So all solutions have two things. So they have the solvent and the solute. The solvent is just the one there's more of. The solute is just the one there's less of. And anything that's in water, we call an aqueous solution. So if you've seen any chemical equations and they have that little symbol AQ after something, that means aqueous solution. And so we'll talk more about that. So anything dissolved in water is an aqueous solution. So pretty much everything we drink besides water is an aqueous solution. Gatorade, aqueous solution. Coffee, aqueous solution. Soda, aqueous solution. Because the solvent in all of those solutions is water. Okay, so, let's think of one. It's like soda. Let's think of soda. What would be some solutes that are in soda? Sugar, CO2 bubbles, right? If it's Dr. Pepper, 23 flavors, right? All of those would be solutes, and the solvent will be water. Okay, so when we talk about molarity and the word concentration are going to be interchangeable for us. So when you see concentration, they're talking specifically about molarity. And molarity is the number of moles of the solute, the thing that there's less of, in 1 liter of the solution. And our formula for molarity is moles over liter. And you see that big M there? So that big M means moles over liters. So again, this is going to be our concentration that we're going to be using. So whenever we talk about solutions, we're always talking about molarity, and molarity has 2 units. So like when you see the little g means grams, right? When you see like the little m means meters. They have 1 unit. But when you see this big M means 2 things. Oops. The big M means moles over liters. So it has 2 units with that letter. So the big M has 2 units. It's going to be different. It's like when you say density, right? So when we say density, the units are always, like, for example, the density of water is 1 gram per milliliter. Density has 2 units. Molarity has 2 units. So we're going to practice with this. So a 355 milliliter soft drink sample has 0.133 moles of sugar. What is the molar concentration? So again, whenever we see that concentration always means molarity. And remember, molarity is always moles over liters. So do we have a moles? Did they give us a mole number in this problem? It is 0.133 moles. So we've got a moles. Did they give us a liter? Not exactly, but did they give us a number that we can get to a liter? Yes, right? So we have our moles, right? That's great. But this was milliliters. So what are we going to have to convert milliliters to? liters. So a lot of times with molarity, they don't give you moles and liters. They might maybe give you grams and milliliters. We just have to convert to the thing that they're asking for molarity. So again, to go from milliliters to liters, gotta remember our metric conversion. There's 1,000 milliliters in 1 liter. And that will get us to our liters. So that's 0.355 liters. And then our molarity is going to be our moles. So moles over liters, and our moles is 0.133 moles over our liters, 0.355 liters. And that gives us, how many sig figs are we going to have? This one has 3 sig figs. 0.133 has 3 sig figs. So we're going to have 3 sig figs. And it is 0.375 moles over liters. And so do you see how this has 2 units here? So we don't leave it as moles over liters. We write it as 0.375 big M. This big M is the same as this moles over liter. So when you see big M, just remember there's 2 units inside of it. So that's how we use molarity. Okay, so the next thing that we're going to talk about are looking at our solutions, specifically concentrated versus dilute solutions. So if you remember, like, okay, let's say you have, has everybody had Country Time lemonade? No? Kool-Aid? One of those two, right? Kool-Aid, it's coming back. Okay, so let's say you had like a tin of like Country Time lemonade or Kool-Aid, and you took a scoop of it, like a whole scoop, and you put it in 1 glass of water. That would be very concentrated, right? Or if you had like, is it the Mios, the little squirty things? You know those sweeteners that you can like add to water? Yeah, so let's say you like squirted the entire thing in a cup of water. That would be very concentrated. Now, let's say you put the exact same amount in 5 gallons of water. That would be very dilute. The only difference between those, they have the same amount of solute in it, the same amount of Mio or Kool-Aid or Country Time lemonade. The only thing we changed is the amount of water, right? So a concentrated solution and a dilute solution have the same amount of solute. They just have a different amount of solvent. So they have a different amount of water in them. And that's the difference between a concentrated and a dilute solution. So when we look at dilutions, so a dilution is just where we take something more concentrated and we add more water to it. And that makes it more dilute. So every time we use a solution in lab, so we're going to be using a lot of solutions in lab. Every single time the lab stockroom, Dr. Rob, you see, Dr. Rob has a big container of a stock solution that's super concentrated. But we don't want the super concentrated solution. We want a more dilute solution. So what he does is he measures out the amount he needs and then gives us a more dilute solution. And so a stock solution, that's the one that's very concentrated. But what we're going to get is we're going to get the more dilute solution. Okay, so for example, you can see in these graduated cylinder, the one on the left is much more, it's much darker than the one on the right. They have the same amount of stuff. And so the same amount of stuff here is copper nitrate, right? And now because we know our nomenclature, we know copper nitrate, right? Copper nitrate, CuNO3, 2 is our copper nitrate. So they both have the same amount of copper nitrate in it. It's just this one has more water in it. So it's a lighter color, right? So the lighter one is going to be the more dilute. That's more dilute. And the other one is going to be more concentrated. So The dilution, there's an equation that we use for this dilution equation, and you're going to see a couple different ways this equation is written. And so I'm going to show you them because if you do look on the internet at all, you're going to see all three of these equations. They really are all the same equation, just people use different symbols for them. And so the dilution equation is always M1, so this is our molarity. This is either it's our volume of our solution. It's the volume of solution. And then this is the molarity 1, and this is the volume 1. And then on this side is the exact same thing. It's just this one's going to be the other piece of the solution. And so you're going to see this a couple different ways. You're going to see this as M1 V1 equals M2 V2. You also see this as C1 V1 equals C2 V2. So remember when I told you that molarity and concentration are the same thing? This formula is using molarity. This one is still using molarity, but it's just using the word concentration. They are exactly the same because molarity is concentration. So don't freak out if you're like, whoa, why is there a C? Why is there a M? M is C because molarity means concentration. Okay, so again, you're going to see these both ways. And so I kind of have both of these here so you can see these. And liters and volume are also the same thing. It's just the amount of the solution. Okay, so when you're using these, this is going to be important. This is going to be one set of circumstances, and the other side is another set of circumstances. So one of them is going to be usually the original, and the second one's going to be a new piece. And so I'm going to teach you how you can see which one is which. It doesn't really matter which one you put on what side, as long as you have the correct molarity with the correct volume. So when we look at this, do you remember when you maybe first learned math equations and you learned like word equations, like word problems, and you were like, wow, what is this devil? Do you remember what the word is means in a word equation? I know they don't teach us anymore. Is means equals, of means multiply. Well, that still holds true here. So do you see this word of right here? It says 0.85 liters of this. So here is our volume. Here is our molarity. This of means multiply. So this is one side of the equation. So you look for that of. That of is telling us those two stay on the same side. Those two are pairs together. So when we do our C1 V1, or I'm going to write it here, M1 V1 equals M2 V2, again, same problem. These are the same. So this would be 0.850 liters times our volume. Well, let me just put the concentration first so it's not confusing. So this would be 5 molar. I will put my sig figs on there in a second. Over 0.85 liters equals, now, do you see it says it's diluted to a volume? So when it says that, it's saying, okay, now we're going to the other side of the equation. And so is this 1.8 liters a molarity or a volume? It's a volume. So when it says, when we do this, what is the molarity of the solution? That's what we're looking for. So we have M2 times our second volume. And then we just solve this. M2 equals 5 molar times 0.85 liters over 1.8 liters, which my sig figs are not correct in there, but we'll fix them in a second. And we end up with 2.36 molar. So again, when we're doing these problems here, whatever the word of is, those two stay on the same side. like 90% of the time, 95% of the time, it's going to say that. It's going to say this many liters of this concentration. So they always stay on the same side. Okay. So this is the dilution equation. Now, again, you'll get this equation. So what I would suggest, there's going to be a lot of equations in this chapter in the next few minutes. I would kind of like have like a piece of paper where they're all next to each other. So when you're doing your homework, you've got all these equations next to each other. Okay. So I'll keep writing them down, but you should definitely have them on a piece of paper so you remember all these equations. All these equations will be given to you on your quiz and your exam. You just need to know how to use them. So it's not going to say, this is the dilution equation. It's just going to say M1V1 equals M2V2. Okay, so here is the whole thing. Oops. By the way, here it is. Much neater and much nicer. Okay, so here's one for you to try. So I want you to try this one, and then we'll go over it in just a second. Okay, so when we're looking at this one here, remember, here's that word of. So that means they go on the same side. Now, I get the question sometimes, does this have to be in liters? Not necessarily, because they're going to be a ratio. But what is important is if this is in milliliters, the other one also has to be in milliliters. Does that make sense? So if this volume is in liters, then this volume has to be in liters. If this volume is in milliliters, then this volume has to be in milliliters. So you need to make sure that the volumes are the same unit for the volumes. Now, if you're like, oh, I don't like doing it in milliliters, you can 100% always convert it to liters and it will always be right. So if you're like, I'm just going to convert it to liters, that will always be correct. You can always do that. So when we do this problem, here's that of. So that means this is our volume and this is our molarity, and the other one will go on the other side. And so if we have our M1, here's our M1 and our M2, and here's our V1 and our V2. All we need to do is plug them in. So we're going to solve for our, here's the math you would have done in on your problem. And then we have M1 V1 over V2. So we plug in our M1, our V1, and our V2. Our units cross off. How many sig figs can we have in our answer? 2. 2 sig figs in our answer. And so we get 1.3 molar as our solution. How are we feeling on dilutions? Good. So when you see dilutions, you're going to see 2 molarities and a volume, or 2 volumes and a molarity. And you're just solving for the one you're missing. Always looking for that word of. Of is the key. Okay, so now brings us to another equation that we're going to use, and this is percent mass or mass percent. They're both used interchangeably. So this is going to be when we're using them, we're looking at the percent. So remember, percent is always the same thing. It's always part over whole times 100. So we're going to be doing a bunch of percents now, percents of different things, but it's always part over whole times 100. And so this case is going to be mass percent. And so when we look at our mass percent, it's written a couple different ways. So you're going to see it's always the grams of solute over the grams of solution. So it says mass, but remember our mass, is always going to be grams here. So this is always grams. So you're going to have grams of our component. So this is our solute, grams of solute over grams of solution. Okay. There's 2 pieces to solution. In every solution, what 2 things are in every solution? Solute and solvent. right? So remember, when we're looking at the solution, it's the solute and the solvent. Both of these things are going to be in our solution. So we need to make sure that we're taking both of these things into account. So we may have to do some little additional adding here. Oops. So we have our solute and our solvent. Okay, so let's look at an example of this one. So what is the percent by mass? And again, you're going to see this, it might say mass percent, and it would say percent by mass. You might see, again, this. That is really common. They all mean the same thing. So you see percents, you see masses, it's always grams of solute over grams of solution. What is the percent by mass of acetic acid in a vinegar solution that contains 2.70 grams of acetic acid and 122.8 grams of water? When you see percent mass problems, the most important thing that we need to do is we need to identify what is the solute, what is the solvent, and what is the solution. Because it's a little bit different sometimes. Okay, so we need to figure out what is our solute, what is our solvent, and what is our solution. Because remember, when we do this, I'm going to put the formula on here so we can do it. It's always going to be grams of solute over grams of solution times 100%. Okay, what is the solute? The acetic acid, because the solute is the one there's always less of. So this is 2.7 and this is 122. Smallest one, always the solute. So our solute is 2.70 grams. Okay, now we need to know what our solvent is and what our solution is. What is water? Is water a solution or is water a solvent? It's a solvent, right? So water is our solvent. So 122.8 grams is our, I'll just put this water so we know which one we're talking about. Okay, so we need grams of solute over grams of solution. So on the bottom, we don't want solvent, we want solution. How do we get solution from these two things? What is solution? It is the solute plus the solvent. So all we need to do is add 2.7 plus 122.8. That is our solution. Does that make sense? So whenever you see water, so if you've ever heard water's called the universal solvent, the reason water's called the universal solvent is because almost everything that we do dissolves in water. So whenever you see water, that's your solvent, not your solution. So when we do this, we take our mass of our solute over our mass of our solution, and here we added our solute plus our solvent. This whole thing is our solution. So, oops, be very careful of that, right? Now, what if I had this over 122.8 grams times 100? Okay, so let's say this is my percent mass. This is the problem. What word in here would change for this to be correct? For this whole thing to be correct. So there's only one word that would need to change for this to be correct. So this 122.8, if it's on the bottom, is it the solute or is it the solution? The solution. So if I change this word water to the word solution, then this would be the correct problem. This would be the correct problem down here. So when you see these percent mass problems, you need to keep a very close eye on these two things? Does it say 122.8 grams of water, or does it say 122.8 grams of solution? Because the problem will be different in that case. Does that make sense? If it says solution, it's super easy. You just take the small one divided by the big one. But if it says water, then you have to add these two together to get your solution. Okay, so we're going to try one of those. Concentrated hydrochloric acid is an aqueous solution with 37.2% HCl that is commonly used as a laboratory reagent. The density of the solution is 1.19 grams per milliliter. What mass of HCl is contained in 0.5 liters of this solution? Okay, so I'm going to go back to the last problem just for a second. Do you see how we used this as a formula? When you're doing all of these problems, you can use them as a formula or you can use them as a unit conversion. You get to decide which one you want to do. You're going to notice in chemistry, there's always going to be multiple ways to solve a problem. Always multiple ways to solve a problem. So if we look at this one here, oh, so many things they've given us. So we have a bunch of different numbers. We have 37.2% hydrochloric acid, 1.19 grams per milliliter, and then we have 0.5 liters. Wow, there's so much. What do we want in the end here? That's the key we're looking for. We want to know what mass of HCl. We want grams of HCl. That's where we need to go in the end. Okay, so let's say no idea. No idea what to do here. So this here is an aqueous solution. So when we look at this 37.2%, so if we look at, remember, percent mass is grams of solute over grams of solution times 100. So we can interpret this in that exact same way. So 37.2% means there's 37.2 grams of HCl in 100 grams of solution. So that is what 37.2% means. 37.2 grams of HCl and 100 grams of solution. So I'm going to write that bigger over here. 37.2%. This means 37.2 grams of HCl in 100 grams of solution. So we can use this percent mass as a unit conversion. Okay. So, and by the way, when you're doing your active chemistry, active is going to ask you to do it like this. They're going to say, I want you to take this percent and I want you to break it into grams of solute over grams of solution. So just be wary. We're going to do a few of those that it's going to ask you to do that. Okay. So now we have three numbers, right? We've learned that when you have a number, you need to start with what they give you, but they're giving us three things here. We have to start with one. Okay, so a good plan of attack in chemistry, for all chemistry, forever, ever that you do, is if you're given more than one number, start with the number that only has one unit. You can start with a number that has more than one unit, but it's just harder. It's always easier if you start with a number that has one unit. Okay, so this percent has 2 units. Grams of solute over grams of solution. That's 2 units. This density has 2 units. Grams over milliliters. This volume only has 1 unit. Liters. Always start with a number with 1 unit. So if we start with 0.500 liters, we need to get rid of the liters. Do you see any unit that they've given us that has anything to do with a liter. Anything. Milliliters. So do you see that milliliters? Okay, we need to use that milliliters, but we have liters. Can we go from liters to milliliters? How many milliliters are in a liter? 1,000. There are, in 1 liter, there are 1,000 milliliters. This is a thought process you're going to be going through all the time with chemistry problems for the rest of the semester. What unit am I at? What unit do I want to get to? Can I go from one to the other? What unit am I at? I am at liters. I need to get to milliliters. Can I go from milliliters to liters? I can. So now we have milliliters. We don't want milliliters. What do we do with the unit we don't want? Where do we put it? On the bottom. It goes on the bottom. Well, now we've got a milliliters. So remember this 1.19 grams per milliliters, this line here, I'm going to rewrite this for you. It's the same thing as this. 1.19 grams per milliliter. That is the exact same thing. Because this line is this line. And if you want to put a 1 there, you can put a 1 there. Some people are like, I don't like it without a 1. So that means milliliters goes on the bottom and 1.19 grams of HCl goes on the top. Okay, now we've got grams of HCl. But we want to know, what is the mass contained in this solution? Okay. So we need to figure out when we do this, oops. Sorry, my computer's going a little crazy. When we do this here, hold on, I'm gonna need a little bit more room. This is our density. Oh, sorry, I wrote this wrong. This is our density of solution, not density of HCl. So this is grams of our solution over 1 milliliter, not HCl. So correct that in your notes. Because right here, this one says the density of the solution, not the density of HCl. So that's our density of solution. So then we've got our grams of solution. So now we can use this unit conversion. In 100 grams of, I need more room again, solution, there is 37.2 grams of HCl. And we get 221 grams of HCl. Now, this is a really difficult one because I want you to see this before you get to your homework. Because you're going to see ones like this on your homework, and I want you to see them here before you see them there. So with this problem, what we did was we just used our mass percent as a unit conversion. So the key to this problem is knowing that this 37.2% means 37.2 grams in 100 grams. So it's changing it from a percent to the grams. And we're going to do this a bunch. Okay. Oh, here's the same thing. I think, yep, just neater. So same thing we just did. I just changed our milliliters to our liters to milliliters right away, but same thing that we just did. Okay. The next equation we have is percent volume. You'll be happy to know percent volume is way easier than percent mass. So percent volume is just the volume of the solute over the volume of solution. And again, write this one down because you're going to need it for your homework. And again, we'll give you these for your quiz and your exam, but we won't say which one's which or how to use them. So you need to identify them. So for percent volume, you just take the volume of the solute, which is always going to be usually the milliliters of the solute over the milliliters of the solution. So if we look at this, here's our percent volume. To prepare a solution, we dissolve 205 milliliters of ethanol in enough water to give a total volume of 235 milliliters. Okay, so we have solute in solution. So the smaller one is always going to be our solute, and our total volume is our solution. So in percent volume, they're a little bit easier. Usually you just divide the two numbers. Small one divided by the big one, and you get your percent volume. This one's a lot more direct. So this one is percent volume. So we've done percent mass and we've done percent volume. Okay. Are we ready for our next one? The next one is mass volume percent. Told you there's going to be a lot of these formulas, hence why to write them down. So our mass volume percent is very similar, except for we have mass on the top and volume on the bottom. So on the top, we're going to have grams of our solute, and on the bottom, we're going to have milliliters of our solvent. So I'm going to write it here too. So percent mass volume is going to be grams of solute over milliliters of solution times 100%. So now we've got five equations that we've done so far. We did molarity, dilution, percent mass, percent volume, and now we're doing percent mass volume. A lot of equations. So in this case, we take the mass and divide it by the volume. And so, for example, if you've ever seen a saline solution, if you've ever seen like an IV, they have like the saline solutions, they're always a 0.9% mass volume. And so what that means that there's 0.9 grams of the solute, which in this case, the solute is salt, over 100 milliliters of our solution. Oops. And so when we multiply that times 100%, we get 0.9%, and it's labeled M/V. So if you ever see a saline bag, it'll have 0.9% M/V, because this is the units we always use. If you have anybody who's going to nursing, you're going to see this all the time. So this is a unit you will see all the time if you're going into healthcare. It's the mass volume percent. Okay, so let's look at how this one works. Okay, so saline is 0.9% mass volume NaCl solution. What mass of sodium chloride is needed to make 50 milliliters of saline? Now there's two different ways you can do this problem. You could do it using the formula, or you can do it using unit conversions. Both ways are correct. You get to choose. I'm going to show you both ways. Okay, we're going to do both ways. The first way we're going to do is we're going to do it using unit conversions. So if we do this using unit conversions, we have this is our solution, right? Solution is 50 milliliters. We can write this. So I'm going to write the formula. Grams solute over milliliters of solution. So 0.9 again is 0.9 grams over 100 milliliters. That is what 0.9% means. 0.9% means 0.9 grams over 100 milliliters. So we can use this as a unit conversion. So this is grams of solute over milliliters of solution. And so if we do that, we have two numbers to start with. We can either start with 50 milliliters or we can start with 0.9 grams over 100 milliliters. 50 milliliters has 1 unit. This 0.9 has 2 units. So if we have the choice to start with 1 unit or 2 units, which one should we start with? 1 unit. So if we start with the 50 milliliters, we can use this conversion, this 0.9 over 100 as a unit conversion. So what will go on the bottom, 100 milliliters or 0.9 grams? If milliliters is up here, what unit do we want down here? Milliliters. So we cross it off. So we can use this as an actual unit conversion. And we get 0.5 grams. Because remember, this, where can I put this? This is 0.9%. So it's just rewriting it. Now, active is going to ask you to do it like this a bunch. So when you see that percent, just remember it's part over whole. So it's whatever the number is over 100 every single time. So it's 5%, it's 5 over 100. If it's 10%, it's 10 over 100. And it's always solute over solution. So if it's 10, it's 10 grams of solute over 100 grams of solution or volume, either or. Now, we could have also done it using the formula. If we did it using the formula, let's gotta erase this. Here's our formula right here, percent mass slash volume. If they give us 0.9%, that equals grams of solute over 50 milliliters of solution. Oh, I'm running out of room. I'm going to write it over here again. 0.9% equals grams of solute which is grams of solute over 50 milliliters of solution times 100%. So then you have to divide by 100, multiply, and you end up with the exact same answer. So this is just the mathematical solution. So you can do this both ways. It's whichever way you feel most comfortable, but I'm letting you know active is going to make you do the unit conversion way sometimes. Not always, but sometimes it does, because for the rest of the semester, we're doing unit conversions. And so it wants you to practice using those unit conversions. So just so you know, come back to this slide if you're having trouble with that part. Okay, so now we've done a bazillion equations. And again, you don't need to memorize these. They'll be given to you. They'll be written just like this on your exam or your quiz. You just need to know how to use them. Okay, so now again, this is just what we're talking about. This is our IV bags that are actually, that have, you can kind of see the 0.9% written on there, mass volume. It's written right on the bags. Okay, so we've already talked about our, just want to remind you, this is coming up again in our next couple of chapters. Remember our Brinkelhoffs? Remember the ones in our diatomics? It's going to come up in just a minute. Remember Brinkelhoff, Brincklhof. These Brinkelhoffs always exist as diatomics if they're by themselves. Okay, this is going to be important. Is Cl by itself? No, so it doesn't have to have a 2. But now, is Cl by itself? Yes, so it needs to have a 2. Is water by itself? sorry, is oxygen by itself? No. So it doesn't have to have a 2. Is oxygen by itself? Yep. So it does need a 2. So these are diatomics when they're by themselves. If they're with someone else, doesn't come into play. Only when they're by themselves. So that's going to come in really important in the next chapter that we're going to be doing. Okay, so that is the end of that chapter.